Namaste, this is Abhishek and welcome to Agri Analyze. This video is about line by tester analysis feature of Agri Analyze. So if you are a researcher of genetics and plant breeding and looking out for end-to-end line by tester analysis along with heterosis, GCA effect, SCA effect of crosses and all this complete analysis along with interpretation and graph, then this video is for you. Now let's see how to arrange this dataset for the Agri Analyze software. So this is the example of line by tester data with 6 lines. These are 6 lines. Then 3 testers. There are 18 crosses and 1 check. Most of the researchers have checks. If you don't have check, then you can delete this check portion. So in order to arrange this data set, we will copy this data. In the new sheet, I will paste this data. Now, first column that I need to make is of lines. Whenever you are writing for lines, then tester component should be kept blank. This is the rows for the tester, so line components are kept blank. And whenever there are crosses, we write for line and tester to mention the cross. And for checks, you need to write the same name in both line and tester. So Arka Rajat is our check. So I have written Arka Rajat in line as well as Arka Rajat in tester. In this way, software will automatically detect the checks. If you have 2 checks, 3 checks, it can analyze up to 5 checks. So you can add the data below. Now this data is for 3 replication. You can see the data is replicated thrice. So I will copy paste this and again paste it twice. Once it was already there and I have pasted twice to make 3 replication data. Now third column I will make is of replication. I will write R1, paste it and make this R1. Now I need to write same for R2 and R3. So I will paste this, replace 1 with 2. Again I will copy this R2, go downside, paste it and replace 2 with 3. So this is my replication column. Now I will add the data. So R1 data is properly placed. I will cut and paste R2 data. Again I will cut and place R3 data corresponding to R3. And you can go to the original sheet. The data was of phenol content. So I will write in D as phenol content. So this is now ready. But most of the researchers have 10 traits, 12 traits, and so on. So Agri Analyze can analyze 5 traits at a time. So you can write, let's say, yield and add the data of yield below and so on. So in this way, you can add 5 dependent variables for the analysis. I have already added, so it will look finally like this. Phenol content, up to phenol content we have already seen. We have vine length, petal length, fruit girth, fruit yield. So this is how I will arrange my data, but make sure that I don't add more variables because it is generating graph and that creates a lot of stress on the server. So we have limited this to 5 variables. If you have like 8 variables, just or 10 variables, prepare 2 files. Okay, replace the variables. Now save this in a CSV format. So I will click on File, then Save As, and in Save As, I will click on CSV UTF-8 and then click on Save. So this is all about generating the data file. Now let's jump to the software and see how to perform line by tester analysis. So this is the website of Agri Analyze. I will go to analytical tool and that select genetics and plant breeding. and select line by tester. I will choose upload file and select the file that we have already discussed. That file was the CSV file that we have saved. Now in line, I will select line. In tester, I will select tester. In replication, I will select replication. Now we will give alpha 0.05 for 5% level of significance. You can also write 0.01 for 1% level of significance. In multiple mean comparison tests, I will select least significant difference test, but there are options for Tuckey test and DNMRT test also. And there is one more feature, that is select traits where lower means are better. So phenol content is for pungency and lower phenol value, that means better is our material. Okay, and rest of the variables are reverse, that means higher values are better. So analysis and interpretation will get flipped for phenol content. It will write in reverse, considering that lower means are better. You can select multiple also depending on your variable. Now I will click on submit. It will ask for some nominal fee and give us the summary that lines are 6, tester are 3, replication 3, total observation 84, and so on. I will click on submit to get the report. Now I will click on download to get the output in the zip. So now let's see how the output looks like. So you will get lot of outputs, and the important one is the Word document. So it will start with basic summary, then analysis of first variable will start, that is phenol content. It will give us the line by tester ANOVA. So replication, treatment, parents versus crosses, lines, tester, line into tester, and crosses was a check because we have added one check also. Then error and total. It will also write about interpretation of ANOVA. Then it will gives other statistics like CD value at 5%, 1%, CV percentage. Then mean comparison test for phenol content for all the crosses. So for this we have selected least significant difference test. There were options for DNMRT test and Tuckey's HSG test also. Now this LSD test has not performed grouping because you can see in the ANOVA the crosses component was found to be non-significant. If this was found significant, then it would have definitely performed the mean comparison test and given us the grouping on the basis of LSD test. But currently we are getting the crosses mean, then standard error and standard deviation. Then it gives us the GCA effect for lines. Then their SE, then GCA effect for tester, their SEs, then graph of GCA effect of lines as well as tester. And then SE effect for crosses, their graph. Then genetic variance components for phenol content. These are the different components. It also gives you the contribution of the total variance for phenol content. Then this is the bar chart for means of the crosses. Top 10 means. Now if you have selected phenol content lower is better, then it will give you the bottom 10 crosses because lower is better. Okay, and then check comparison. It also gives you the interpretation for GCA effect, SCA effect, and the most important stuff, that is heterosis over mid parent. Then it will give you heterosis for the better parent and standard heterosis over the best check, that is Arka-Rajab. Now it will repeat the same analysis for the other 4 variables that are left out. So it will give the analysis for rest of the 4 variables that we have selected. Now let's see what other stuff. So all these graphs that you have seen are also given. So these are all the graphs. Separately, it is also given. And we are given 3 Excel files. So this is the clubbed ANOVA for all the 5 traits. So this is the ANOVA format that we keep in the thesis. You can directly use this for all the 5 variables. So the values are the mean square and their significant, that is result. They both are uh, concatenated. Now let's see what other Excel files have. So this gives us the GCA effect of lines. So GCA effect for all the 5 variables, GCA effect of tester for all the 5, SCA effect, contribution. So all this stuff are made in such a way that you can directly add this in your thesis. Now heterosis for mid parent, better parent, and heterosis for the check. So, and lastly, we are getting mean table. So this is the two-way mean, like this is the crosses mean, and this is the tester mean, this is the line means for all the 5 traits. So I hope that you find this feature useful, and it's covering almost 99% stuff that is required for the analysis of line by tester. Thank you for watching this video.